Hello, today we're going to talk about solids, liquids, and gases. Okay, so just some general properties, solids, liquids, gases. Solids and liquids both have a definite volume, which means the volume stays the same no matter what container you put it in. Liquids and gases both have a definite, solids have a definite shape. I'll write it like that. Liquids and gases have an indefinite shape. Gases also have an indefinite volume. Gases will spread out to fill up the entire container. Liquids do not. Some other general kind of properties that you need to know: solids tend to be the most closely packed and the most ordered arrangement of particles. Liquids are going to be kind of in the middle. Gases are the least tightly packed and the least orderly arrangement. Solids will have the most intermolecular forces between the particles. Gases will have the least intermolecular forces between the particles. Let's see, what else do you need to know? Solids can be organized into crystalline solids or amorphous solids. So crystalline solids will have a very, very orderly arrangement into a crystal, but amorphous solids will be less organized. Things like glass is an amorphous solid. Most plastics are amorphous. Gels tend to be amorphous. So it really depends on the solid. So if we're looking at phase changes or changes of state, they can be classified as either endothermic or exothermic. If you're going from a solid to a liquid, that we call melting, or sometimes we'll call it fusion. The reverse, liquid to solid, is freezing. And then if you go from a liquid to a gas, the general term is vaporization. That can be evaporation or boiling. Gas to a liquid would be condensation. And then you could also go directly from a solid to a gas. That is sublimation. You can also go from a gas directly to a solid, and that is deposition. Now, the endothermic ones are the ones that require an input of energy. So I'm going to go ahead and mark those with a star. The solid to liquid, that is endothermic. Liquid to gas is endothermic, and solid to gas is endothermic. It requires an input of energy. The other ones are exothermic. Liquid to solid, it has to get rid of some of its energy. Gas to a liquid and gas to a solid. Those are exothermic. Exo and endo. So what state of matter a substance is at any given time is determined not only by the temperature but also by the pressure. So pressure will determine how closely packed the molecules tend to be, and will affect the state as well. We'll get into that a little bit more when we talk about gas, the gas laws, when we are calculating gas pressure. But for now, phase diagrams tend to look something like this. Now, they might be a little bit different, different slopes, but you'll have solids, liquids, and gases. And it's dependent on both the pressure and the temperature. And so, most of the time we talk about changing phase as going from a solid liquid to gas, so it would have to go like this. Now, if you keep the pressure constant, it's going to go, in an orderly straight line like that as you heat it up. But if you're changing the pressure, you can also change the state of matter, just depending on what's going on. This point where all three intersect is called the triple point. This one is the critical point, past which you get a supercritical fluid. And then if it's directly on a line, that would be considered a phase change. So here you have sublimation or deposition. Here you would have melting or freezing. And here you would have condensation or vaporization. Now make sure that you're able to draw particle diagrams for solids, liquids, and gases. Solids, you tend to draw them very closely packed together and in an orderly arrangement typically. Liquids, you want them still fairly close, but not so orderly, and you want to make sure that if you have a container, it's going to like spread out along the bottom of the container. Solids don't do that. They'll just kind of sit in the container where they are. Liquids are going to spread out. Gases, on the other hand, when you have a container, you want it to completely spread out throughout that whole space. Those are your particle diagrams.